All right, so let's start. And this is the second time we'll talk about LaTeX. So on Monday, I just kind of threw you into LaTeX and you tried out some things. Today, what I'm going to do is more systematically go through with you the various components of LaTeX and just give you a more systematic perspective on how to do things with LaTeX. I have this file here, which is 2016-0420.tech, which you should be able to find in your project for the class. It is a tech file, which I'll talk about line by line, but also on the right it has kind of the content for what we're talking about today in class. And also inside of it there are some exercises like this, which you'll do by editing this file, okay? So you'll want to open this file in your project. I started the screencast, so that's there. Open this file, that's the second thing. And then the third thing is a reminder, the homework and pure grading is due at 6 p.m. on Friday. So the homework is to reproduce some PDF files using LaTeX, find a cool example, and fix some errors. And the pure grading is grading what happened last time. Okay, any questions about the homework or pure grading? Okay. All right, so let's get started with this. So first, I'm going to tell you kind of line by line what goes into creating what's on the right-hand side. So maybe I'll make this more full screen so we can see more. Okay, so the first thing is that in LaTeX, unlike in Python or other languages you may have used, the comment is a % sign, okay? So it's probably different than every other programming language or markup system that you've ever used. And what happens is that you put the % sign at the beginning of the line. So every single line you want to have commented out, you have to have a % sign at the beginning. And SMC and many LaTeX editors will helpfully color the line differently to show you that it's been commented out. Okay, so that's the first thing right here. Second, there's the preamble of the document. That's everything from document class through begin document. So it's what I've highlighted right here. Almost every LaTeX document will have document class or something similar, and then after it, some description of the type of document. It doesn't have to be article though. There's many others. There's letter, there's like quiz, there's book, report, etc., etc. There's a whole bunch of different, or hundreds and hundreds of different potential document classes. And if you select a different one, your document can look completely different. It's kind of like, it's almost like a template in other environments. So in the preamble, typically you define stuff. It's kind of like the head in an HTML document. So you'll include packages, you'll maybe define some other macros and call functions and so on. But nothing that you put in the preamble just directly immediately gets typeset. Whereas the stuff in the body of the document, which is everything from begin document or whatever, I mean, it might not be document, but usually it's from begin document to the very end of the document. That's the stuff that gets typeset pretty much in the order that you put it there. By the way, there's code folding. So if I click on the little triangle, I can fold various sections of the document. See? So like if I want to fold the entire document, I click here. And you can also fold other things like the enumerate environment. You can fold just that, so you can get it out of the way. You can also, if you highlight everything and hit Control Q, it will fold every single thing that it finds in there. And when you expand it, it'll only expand at the top level unless you highlight it again and hit Control Q. Control Q just goes through every possible range and folds it. And so this kind of gives you a top level view of the document. On the other hand, if you're at some point over here and you want to get back to the point in the document that you're editing, you can double click, and then that will take you to the corresponding point over here and expand it. And likewise, if you're over here, say professional looking, if you click on forward, it takes you to this point on the right-hand side. This doesn't matter very much for a 1 or a 2 page document, but if you're writing, say, a 50-page document, it can save you a lot of time and frustration. Okay, back to our line-by-line analysis of this document. The next line, line 4, I'll zoom in a little so you can see us better. So this says it's an article. There's various options that can go here. I put 12 point as one of the options. The default is 10 point, and by putting 12 point, it makes the font bigger. So there's a number of options you can give. There are other options like draft, etc., which will make big black boxes that indicate where things are overflowing and so on. So LaTeX goes through the whole document and tries to make it typeset perfectly by this. It's kind of an optimization problem. Where should you break the lines so you can make things look ideal? But sometimes it can't do that, and so like some line will have a word sticking out on the right-hand side. And so if you put draft here, then it will like very clearly indicate it with a big box. And typically what you have to do if things get messed up like that, if there is no good way of typesetting your document, is you'll reword things a little bit to make it look good. So that's what this line does. Title sets the title of the document. Author sets the author. Date. If you leave out date, every time you typeset it, it'll typeset it and show the current date, which I think with SMC, for better or worse, will show you the current date in England because the time of the server is set to UTC, which is one of the time, like it's time zone 0 in terms of offsets. And so it's usually good to just explicitly specify the date. Here's a package. So in Python, you do import and then module name. And in other languages, you have various ways of importing extra code. And in HTML, you have something. In LaTeX, it's use package. So what that command does is and there's, again, thousands of packages for LaTeX at this point, since it's been used and developed for so long. This includes the hyperref package. If you wanted to find out a lot about this package, you could just type hyperrefs LaTeX into Google, and you'll find lots of documentation about it. And that's the case for pretty much every imaginable LaTeX package. What happens when you do use package hyperref is that suddenly there are some new commands that are available to use inside of your LaTeX document. They're not namespaced at all, like in Python. So it's not that you do hyperref dot something. There's some other commands. The one that I know of is \URL. I think there's also a \href. And for all I know, there's a whole bunch of other commands that get added. I have absolutely no idea which ones got added by including that package. The only way you can know what happens or what's supposed to happen when you do use package is to look at the documentation for the package. And typically you'll use this because you'll search around online to try to figure out how to do something, and it will say, oh, there's a package to do that, and you'll include the package, and then you'll use some snippet of code that accomplishes what you want. But you can imagine how this could get you in trouble, just due to the lack of any namespaces. So the reason that I did this is because I want to include some links in the body of this document, like this one right here. See, that's a URL. And I want to make it so that it looks nice, and you can also click on it, and it will go to that link. And that's what happens. If you were to click on, I guess, this download button, you'll get the original PDF, or the built PDF version of the document we're looking at. And because I used the hyperref package, notice that my little mouse, like right here, it changes to a little finger. When I go over this link, I can now click on the link, and it will take me to that URL. See? It's bringing up that website. Also, just because I included the hyperref package, there's also lots of cross-referencing within the document that automatically gets, well, let me go back, but whatever. I'll just click here again. There's lots of cross-referencing inside of the document, and I'll talk about this a little bit in a second. But notice down here, for example, let's see. Okay. This is section 3. The next section is section 4. You can reference anything. So I'll show you how in a minute. It's really, really easy to make cross-references from one point to another in a LaTeX document. By the way, this is one of the things that's somehow much easier in LaTeX than in most other document editing systems. When I click on this, though, it'll take me to section 1, which is kind of nice. See? That stuff doesn't work over here. This is just a preview. It's not the actual PDF file. You can get the PDF by clicking PDF right here. But then you can't do the click to get back and forth thing and it only updates when you explicitly click PDF. The preview, it's just an image. I wrote some code on the server that takes the PDF and turns it into a PNG image and displays it here. And then it does the appropriate linear algebra and math so that when you double click on a point here, it takes you to the corresponding point on the other side. So that's what this thing is on the right. It's actually just an image. If you want to change the resolution of the image, if it's too low or high, you can click on this thing with all the dots, and then a menu comes up and you can change the DPI of this preview. But even on a Retina display, it looks pretty good at that resolution. Okay, so that's what hyperref does. But basically, I always include hyperref in documents because I want to have nice cross-referencing and so on. Okay, another package, one of my favorites is GraphicX, which I've been using for like 20 years. And what it does is it lets you put images, like PNG images, apparently now JPEG images, PDF images, etc., anywhere inside of your document. So if by any technique, anywhere you somehow got an image, like by a screenshot or exporting from another program, and you want to stick it in your LaTeX document, you can use this use package GraphicX package. And I'll show you in a section below how to use it, but it's pretty straightforward. You just put this here, and then suddenly there's an include graphics command that's available. Okay, another thing, there's another package called AMS Theorem, or AMS-THM. That's what this is right here. Zoom in. That AMS is the American Mathematical Society, which is a not-for-profit organization in Providence, Rhode Island that represents professional mathematicians across America. And their name is AMS. And they do a lot to support LaTeX. And in particular, they maintain a package called AMS-THM, which lets you easily define little environments that make it so you can put theorems, propositions, exercises, definitions in your document with just like just a few lines of code. And so it looks really nice. So what this does is it makes those commands available. In particular, it makes the command new theorem available. And by saying new theorem, exercise, exercise section, what all that does is it makes it so that I can now type begin exercise and exercise, and then put the exercise inside, and it will automatically put numbering on the exercises, it'll indent things, etc. So, and there's also something similar for actual theorems, propositions, and so on. And so you can very cleanly and in a very semantic, meaningful way write a LaTeX document where your theorems are explicitly described as theorems in a block, and your definitions are described as definitions, and so on. So it's really, really different than how you would write a Word document, where you just kind of hit the bold key and then type the word theorem and try to make it look good. But it's all about kind of how it looks in Word, whereas in LaTeX, it's all about the meaning of what you're writing. And you can change the way it looks with just a few commands at the top of your document. It's much, much more like HTML and CSS. So just for example, here's what I did above is I defined an exercise environment, and now anywhere in my document I can put begin exercise, and then put some code inside of there. And then if you look at what happens, over here it'll automatically insert a number, and the numbers are auto-generated, so notice that one's 2, 1, and 2, 2. And some of the options I put in the new theorem command specify how this numbering should work. Should it be like one global counter throughout the whole document? Should it reset the counter within each section? Etc. And you have total control of that. You can do it one way, and then with one line change at the top of your document, you can completely change how everything's numbered throughout the document. And so you specify the meaning, not the markup. Like you may have, if you've written in Word, you'll end up sometimes explicitly typing exercise 2.2. Like you'll actually type the number, and then you'll decide you want to move things, and then you'll type it differently. I mean, of course, there are better ways to do it, but in LaTeX, you really, they make it ridiculously easy to just automatically construct all these sequence numberings and so on. Okay, so there's that, and notice there's this. Okay, so that's what this line's about. Now we begin our document by saying \begin document, and then here it says \make title. And what that does is it takes all the information that we gave it about the date, who's written this document, what title we want it to have, and then it inserts it right here in the document, namely at the beginning. But if you took this, maybe made a copy of it, maybe put another copy of it inside this section, just wherever you put it, it will automatically generate the title when it runs that command. This is the way you call a function in LaTeX. Basically, you say / function name with some options optionally. So should be a whole bunch of titles. Maybe it only does it once. Let me get rid of this one. See what happened? I moved, okay, you can only do it once, but I moved the make title inside of this section. And what it did was it started making the section, and I'm going to get to sections in a second, and then it ejected the page, and then it made the title right here inside of the section. So that's what make title does. Okay, I'll put back the normal make title because I don't want it to be down there. So if you didn't have this here, if you just deleted make title, then the title will just disappear and your document won't have a title. Okay, next, inside of the document, optionally, we have a bunch of sections. If the document were bigger, or a book, you might have things like begin chapter. Or actually, no, it wouldn't be begin chapter, it's / chapter. This is just a shorter document, so we have / section. There's also something called LaTeX Beamer, which lets you use LaTeX to create slideshows that look like PowerPoint-style slideshows. And there, instead of sections, you have lots of frames. And you do begin frame, end frame. So there's just a huge amount that you can do with this. Okay, so what / section does is says everything starting here is part of a section. And then you write a bunch of paragraphs and environments and so on. You separate paragraphs by one blank line, at least one blank line. That's the main way in which white space is significant in tech. It's not too significant, but it has some significance, kind of like in Python. The indentation almost never matters. Like notice I didn't bother indenting anything here, though I could. Okay, so here we have a section, and there are some funny things you can do. For example, if you put a star, an asterisk, right after the section command, then it will not number it. It'll be an unnumbered section. You'll still have the header, but there's no number next to it. Notice that the 1 just disappeared. And then the cool thing is that all the other numbers got updated. So it changed from 2, 2.1, et cetera, to 1, 1.1, et cetera. Yes?
So I've been typing for a little bit, and sometimes is there a way to suppress the number from showing up without, but it still increments the counts?
Yes. I can't remember what it is.
Okay, I'll look it up.
Definitely, yeah. You can also just, you can explicitly, they're just counters or variables in a programming language, so you can do kind of anything you want to them once you know what they're called.
Well, really my problem is there's a certain command environment or whatever package I want to use that depends on the numberings, but I don't want the numbers to show up. I'll figure it out. It
depends on the package. I don't know. By the way, there's other cool things you can do, like make title, which I didn't put in here. Table of contents. That's a command which will analyze your whole document, figure out what all the sections are, and then make a table of contents at the top. And the reminders one is skipped because it doesn't have a number. It's not supposed to go in there. But notice suddenly I have a table of contents, just like that. And sometimes it's really useful to have that when you're writing the document, just to keep yourself organized, and then you just comment it out or remove it when you're actually making a document available to other people. And this is also hyperlinked. So if we were to go over to the PDF file and then refresh it, then notice my mouse is changing to a little hand, so I can click on one of these and it takes me to the corresponding point. So you get a nice automatically generated table of contents, just like that. And you just have to type table of contents, and it just inserts it. Okay, so now we have a section called math formulas. Let me actually tell you about some of the content. Well, actually here I wanted to tell you about functions a little bit more. In LaTeX, you can define new commands. So we were calling some commands, above we call the table of contents command. But you can define a command, let's say hello. And here's how you do it. This is a pretty simple example. But if you find yourself repeatedly doing something over and over again in a big document, just like if you just understand this one line, you can save yourself a huge amount of typing. So you say / new command, and then you say / the name of the command. You'll get an error if the command's already defined in LaTeX. So you can only define new commands this way. If you want to redefine something that's already there, you do renew command, which you probably don't want to do because you can mess things up. But if you do new command / the name of the thing you want to define, it shouldn't have any numbers in it. It should just be letters. Numbers end the command name, so that's confusing. Then you give the number of arguments in a square bracket. So this command takes one argument, doesn't have to take any. And then you give what it should get replaced by. So this can be really, really complicated, but in this case, everywhere that you put / hello, it's going to replace it by hello and then that first argument. Okay? And you could use the argument repeatedly if you wanted, like that. And now, whenever I say / hello and then give a little string, it'll replace it by this right here. So it'll replace. This is going to say hello world world ! Twice. Okay? And then the second one will do something as well. Let's see if what I said is true. So it has to type it. Yep, see? It changed hello world world ! Twice. I say hello to you. So you can just change it however you want. And you could call other macros from within here and so on. Or macros, other commands. Obviously this isn't called a macro because right in it, it says new command. So I better call it a command. Just what it is. As I've mentioned a million times, and I'm sure you're aware now, since LaTeX has been around since before many of us were born, there is a huge amount of documentation available online, and there's a billion books on it and stuff, so which are necessary because it's not easy to use without documentation, unfortunately. That said, once you have a document that kind of looks good and does what you need, you can very often copy and paste from it to make your next document. So it's kind of like pretty easy to reuse bits and pieces of LaTeX elsewhere, which is not always the case for programs. Okay, so now something about actual LaTeX. So if you Google for LaTeX symbols, so there's lots and lots of nice, pretty symbols like right here that you can typeset really, really easily in LaTeX once you know what they're called. Like any Greek letter, many things like big pluses and intersection signs and all this sort of stuff that comes up in math. You can just like bang them out on the keyboard if you know what they're called in just a fraction of a second. You don't have to like find them in some menu or use a funny keyboard or something. So for example, like this one is \xi with a capital X. So it's really easy to type once you know about it. See? And then also, let's say you find yourself typing var phi a lot. That's this kind of calligraphic phi symbol. You can just do \new command and then make a like a 2-letter command for that particular symbol, and then use that everywhere else. And you can like build up a whole bunch of commands like that. So you can use really complicated, beautiful symbols and then type them in very quickly in LaTeX without ever having to click on any menus or anything like that. I mean, just to illustrate that, look, if I want to do consider var phi plus psi cubed, like I could just type it really quickly. And I'm not like slowed down by having to use menus or anything like that. By the way, the top hit for me when I type LaTeX symbols is this website right here, which actually I already have up. It's something called The Art of Problem Solving. I'm curious, actually, since you guys are in high school recently, have any of you ever heard of this website? I see a little interest. I guess it's aimed at like people that are really into math in high school and like math contests and that sort of thing. So it's a big website. What? No, it's not aimed at that?
I think my little brother
Yeah.
might have done something like that.
Okay.
I'll check it.
All right. Well, part of the reason I'm mentioning it is because I'm going to dinner with the people that run this site and the founders on Friday, coincidentally. So I will find out more about it then. But it turns out they have a bunch of stuff about LaTeX because they probably use it a lot for their online sort of problem-solving discussions. Any questions? Yes?
I just want to make a comment, like if you ever know what a symbol looks like, but don't know what the command is, you can go to detectify and actually draw it out.
Ah,
It's really cool.
I found another one kind of like that, which I'll talk about in a second, but it's not detectify. But it's, what is it? Let me bring that one up too. Detectify. I guess it's a competitive space of trying to do this lot. Oh, that's cool. It's all skinny. So I really need to do alpha. Ah. It's hard for me because I'm not fair. Curly equals prec. Wow. That's it. Okay. That's impressive. Look at that. So just like that. So omega. Hey, works really well. So I'm going to add that to the document. URL detectify. Okay, so there's that. There's another one that web demo. Let me show you this one. It lets you do whole formulas. I think it's some kind of startup. They emailed me, like they cold emailed me maybe a month ago saying, you should pay us to make it so that this little thing is inside of SageMathCloud so that you can use it there. And I didn't do that, but it lets you do like omega plus alpha cubed. So you could type like a whole formula, and then it down here it tells you the LaTeX. It's pretty damn accurate actually, and you rate it, and then I don't know about this thing on the right doesn't look so good. The whole page looks like not so beautiful. In case they noticed the screencast recording from my designer perspective, but it is shockingly accurate at like getting what you write to turn into tech. So notice that figures out how to make a fraction in tech and so on. And I could just take this, and then I presumably can go over here and then just make it a displayed equation and see what happens. I've never heard of defrac. I'm a little suspicious. Yeah, I don't know what defrac is. There's a command frac, which I don't know what sort of assumptions they're making.
I think defrac is supposed to be for small fractions. I don't know you're wrong.
Yeah, it just gave an error when I tried it, so it's not there by default. They probably have a list of packages that they use. Okay, so let me tell you just a little bit more about, so that's how you can find symbols and how you can kind of do quite a lot of stuff. Here's a bunch of hints about how to typeset specific things, just kind of some basic principles, which you'll notice if you were to use the website a bunch, but here they are. I'll just tell you about them. It's just like 4 or 5 things that if you know, you can typeset quite a bit pretty quickly without having to use any website. So again, I'm just making this big. So let's talk about a couple of these. So exponents or powers, you say the thing, and then you put a caret symbol, and then you put what you want in the exponent. And if what you want in the exponent is like more than one identifier, then you have to put it in braces. Otherwise, it won't work correctly. It won't know how to, like, look, if I do exactly the same thing without the braces, and of course, notice that the braces are not explicitly visible. They just group in the formula, but they don't actually, you don't actually see the braces. Of course, the critical thing is how do you put braces in? But notice what happens if I don't put the braces. There's that ambiguity. It's kind of like what you would do with parentheses. However, notice what happens if I try to do this with parentheses, which is what you would probably think you want to do based on your experience with programming languages. It will fail miserably. Watch. Like really, really bad. See, that's not what you want, is it? See? That's horrible. Couldn't be worse. And you'll occasionally see that sort of thing in LaTeX. But in LaTeX, this is like the one thing you should remember from today. In LaTeX, the grouping symbol is braces, curly braces, not round parentheses. So, and they don't appear. So if you just remember that one thing, you've learned something really useful as far as being able to type stuff out. If you want to put a brace in, you can do this, \brace. It's like an escape command. X, I don't know what I'm doing. Q. Ah. So when it compiles this, you'll see that there are actual braces. Unless, let me make that BF. There's some package that gives you BB. So notice that we have actual braces over here. So if you need braces, you put \, and then the brace. It's like an escape, kind of like, well, it's just an escape thing that lets you do the symbols that have some special meaning. Similarly, I think if you need an underscore, yes?
Would math BB also work in place of math BF?
That's what I just tried to do, and it didn't work. And the reason's because I think there's a package which I have to include to make it work. And I think the package is amssim.
Yeah.
And then I'll go up here and do it. Yep, use package amssim for American Math Society symbols. And then when we go back down here and compile, it'll suddenly work. And you get a beautiful Blackboard bold style Q, okay? Which you'll see that it's kind of popular in math. It indicates the rational numbers. Okay, so power subscripts, you use an underscore. And again, you have the exact same issue with braces and parentheses. And you can combine them. You can put a caret for a superscript and an underscore next to the same symbol or expression or whatever, and you'll get a superscript and the subscript all at once, right on top of each other like this, as you can see. Fractions use \frac, and then you give, it's a function that takes two inputs. The first input is the numerator, and the second input is the denominator. And you can make these inputs ridiculously complicated. Like you could have, I don't know, like some really complicated thing in the top here. I don't know if I can use that hello macro that I had before though. We'll see. I have no idea if this will work or give an error. It worked. So I just replaced 10 by hello 10 exclamation point. See, and that's what we got over here. The reason it's all in italics is because it's just a bunch of letters multiplied by each other, multiplied together. Here's an example of an integral. So on the left, I put \int, and the thing I get on the right is a nice integral sign. See? So in order to typeset this thing that would probably be somewhat tedious to typeset in some graphical editor or something, you just type \int, that's it, and then the subscript is 0, the superscript is pi, and then you put something after it. So it's really short, actually, and quick to typeset this. Like that's all you have to type with your fingers to get some definite integral with endpoints and so on. And you could just omit any of the endpoints, or you can make them, arbitrarily complicated if you want. That doesn't mean anything anymore, but whatever. So see? Oh, and to make it displayed instead, use $2 signs instead of 1. There's also a bunch of stuff for making like a multi-line formula where you have equals from one step to the next, where the equals are all lined up, for arrays, for tables, for matrices, etc. And I'm not getting into any of that. One kind of cheat way, if you have something that came out of doing a calculation in Sage and you want to just stick it in your LaTeX document, is there's a command LaTeX of an object in Sage. And if you just run that, it gives you back the LaTeX that you can then paste into Sage. So for example, if I do, I don't know, sine of tan of x dot series expansion in x to 8 terms. So this is kind of symbolic calculus stuff in Sage, which is the topic for next week, by the way. And then if I do LaTeX of that, it will tell me the LaTeX that I would type in to get that expression. So this is going to look like a nice Taylor series when I type it in, or when I paste it in. So this is kind of like, I don't know, dangerous version of SageTech, which you learned about on Monday, because you're copying and pasting. which is just begging for trouble, but anyways. It's a little annoying, actually. It doesn't look perfect, because look at these parentheses. They look kind of funny. I'm disappointed in that, to be honest. So like this LaTeX thing, what happened was I'm like, geez, wouldn't it be nice to be able to just say LaTeX on something and it would work? And so I started implementing a LaTeX method on lots of the objects in Sage. And lots of objects are built up out of other objects, and so it kind of would recursively call that method. So for example, for rational numbers, it is pretty reasonable. But I don't know what's going, like you end up with, there's parentheses around something, and then you don't know if they should be big or small or whatever, so it's not perfect. Yes?
Wouldn't slash left always fit it correctly though? Like
Probably. I'm very much wondering why there isn't that. Why it doesn't have that. Sage could be modified to be better. Let's just say. Sage is not quite perfect yet. In any case, and let me show you another example. Let's say you want a matrix. I'll make a random matrix over the rational numbers. So I'll have fractions. Hey, that's not a very good random matrix over the rationals. Okay, there's a better one. So that's what it looks like. Show uses tech behind the scenes. You can also just right-click on this and then do show math as tech commands. And it'll give you something which you can then paste in. And it will look like that when you typeset it. So that's how I got this. And in a moment, we should see a matrix appear on the right that looks just like in the output of the worksheet. Kind of just doing the problems I suggested. Okay, so you get a matrix like that. There's also a command in Sage matrix rather than just random matrix, which you can put any entries you want in. If you say LaTeX of it or show, so you can also say LaTeX, then it will give you the LaTeX you need to construct that matrix. See? So it just outputs the LaTeX right there. And Sage Tech under the hood, it uses this. For some reason, I'll put it twice. Okay, so Sage Tech under the hood, by the way, calls the LaTeX command and then sticks it in the LaTeX document. Okay, moving on. So I have two exercises for you to do, but I just did them right in front of you, so can't really be boring probably. We already did this random web page. So the last two topics are sectioning, cross-referencing, and graphics. So I'm just going to tell you about these really quickly, since we still have time. Whoops. Actually, let's do graphics and then cross-referencing. So I'll do it in reverse order to mix things up a little. Okay, so you want to include a picture of your skateboard ramp in your LaTeX document. So you want to know how to be able to do something like that. Okay, so just anywhere in your document, you want to have it just have a picture you took just appear. That is indeed my skateboard ramp, by the way. So what you do is, it's pretty straightforward. I can show you. So here's what I did. Sorry about this. Close your eyes. Okay, there it is. This is all I do. You just do begin center. Well, you know what? This is just because I wanted it in the center, but you can put this anywhere. You just say \include graphics, and then you can specify a width optionally. You really probably want to because pictures are often huge. And a good way to specify a width is as a multiple of the width of the page. That's what that does. That says it's 0.6 times the width of the page. And then in braces, you give the file name. If you look in this directory, there's a file svr, which stands for seattlevertramp.jpg. And there it is. And so it just it just puts that in the PDF when it's generating it. You could use this image like as an input to a command also. Watch. I could do \hello and then make the name be this image and then make it like a width of 0.1. And hopefully it's going to suddenly have a little teeny image somewhere in line here. Look. So it worked. So see how flexible that is? LaTeX is very composable in that you can figure out how to do something and then you can just feed it in, like where you can put a letter, where you can put in, like anything you can put anywhere, you can kind of put some really complicated thing. So if you figure out how to make an image, then you can just stick that image kind of anywhere, which is pretty cool. I don't know whether you can put it inside of a LaTeX formula, but I'm suddenly very curious. Wouldn't that be crazy if I could do x to the power of my skateboard ramp? We'll see. I've never in my life tried this, but I'm about to see. Wow, you can do it. Look at that. So, yeah, so you can put images inside of formulas, just wherever you want. Okay, so LaTeX is pretty powerful, you have to admit, right? It's a very, very different tool than Microsoft Word. Like, they're just completely different universes. Even though, at the end of the day, you hopefully get a nice-looking PDF out of either one. And those are really kind of the two, directions as far as creating documents go. There's the Word sort of direction, the WYSIWYG editors, and then there's LaTeX, and they're completely, utterly different. Okay, so that's how you include graphics. That's it. I mean, it's just there's an include graphics command. And you can get the graphics from wherever. Oh, the one other thing I wanted to point out is that in Sage, let's say you draw a nice plot, like plot sine of, 1 over x as x goes from 0.1 to, actually make it from 0, let's see what happens, to 10. So you're like, this plot looks great. So one thing you could do at this point is like screenshot it and then get the image and then put it in your LaTeX file. But something much better is you can maybe give it a name and then do g.save a.pdf. What that'll do is it'll create a PDF file, which is called A. You can click on it here and you'll see it. You could download it, put it anywhere you want. And you can also include it in the document in the same way that we've been including other things. So I can put a.pdf right here. And in a moment, it will appear here. So see, there's a little tiny plot of sine of 1 over x as the exponent of, this is hard to do, of x in that equation. Okay, so again, the key thing that I just showed you, which is a very useful thing to know, is that given any graphics object in Sage, at least any 2D graphics object, you could do .save and then give a file name, and it will save that graphics image to the file, which you can then use in other places, like in the LaTeX document, or you could, also include it in a Word document or something. You could download it and drag and drop it. Okay, what else? Okay, and then the other thing I want to tell you about is sectioning and cross-referencing, which is, of course, a really important basic idea in LaTeX. And let's go to that section. But basically, you say backslash section to make a section, as I showed you, backslash subsection to make a subsection of the section, backslash subsection to make a subsection of the section, etc. And then you can do cross-referencing by putting backslash label and backslash ref anywhere you want. So just anywhere in the text, like say at the beginning of a section or something. Let me see where I've done that. Backslash, you say backslash label. You won't actually see anything, but it'll invisibly insert something that you can reference elsewhere in the document. Okay, so right here, I put backslash label, and you can give it, there's a pretty wide range of valid names you can give the label. So you say backslash label, and then you give some sort of name, and I don't know what the rules are for the names, actually, but apparently a dash is okay. Then you can say anywhere else in your document, this is section blah, and it will automatically figure out what the number should be to put there. So it doesn't matter where you put this. So these two things go together, backslash label and backslash ref. So for example, here I say backslash ref reminders. What's important is that somewhere else I have a section that has backslash label reminders in it. So there's just two commands, backslash label, backslash ref. And it works, it's not just for sections. Remember up here we had a list which was numbered, right here. And you can put a label in here. I actually put one in the last numbered thing. Homework and peer grading are due Friday at 6 o'clock. I put backslash label reminder homework. Now, anywhere in the document, I can put backslash ref reminder homework, and it will replace that by a 3, because it's the third entry in here. Okay? So, and if I move things around, just like reorder this, it'll automatically fix everything immediately. And that's everything I wanted to tell you, so I'll answer your question.
So that works for any kind of like command that's Give something enumerated, like you just put the label after it. And then,
Yep. Or somewhere in here. I don't know the exact rules. Maybe nobody does, but all right. So I don't know. Try to do one of the exercises in here in the remaining 5 minutes, and I'll walk around and answer any questions you might have. Okay. Yep, you don't even need to assign it. Just you look, you'll find that, oh, it should be a.plot and a.pdf.
Oh, a.pdf.
Yep. And if you were to say a.png, it would make a PNG file. It figures out what type of file to make based on the file.
Okay, so
Maybe. I don't know whether we support that.
okay.
We might.
And then as far as following,
You have to do use or include graphics like I have there. You also need to use package graphic X. So if you look at the example from today, then you should use that class and stuff. If you just go to your project and your files, should be that file right there. Although, yeah, this is it. So if you look at the very top,
between.
the preamble, it has use package graphic X. You might want to, you can. Yeah. Do g.save and then give the file name as a string. You have to give it as a string. Yep. You can, absolutely. And we'll make a PNG file instead of. Either one will work. Yeah. PDF looks better. Yeah. But the PNG could be better. And it's just like silently there. If you click on files, you'll see this version.
So how much would boxers say?
Literally just 2 parentheses, 2 times x. But you have to do asterisks. Yep. And then cool. We'll do a lot of that next week. Sure. What's your question?
Okay, so for like graphics, I have this. It's just like a PDF
Sure.
or whatever in the file.
Yep.
And then when I go to import it,
Yep. Yep.
it doesn't.
It should give you like maybe the first page of it.
Right.
There's an
yes.
error.
Yeah. Yeah. So I guess like the problem I'm having is that like when I like go to upload this, I just like choosing a random PDF. So does that mean that it's like already in my
Oh, you just bought it?
yes,
file
It'll appear in the directory that you uploaded it to.
there? Right.
So like
Yeah.
plot
Okay. Okay. So
Yeah.
it's already.
Yep. And there should be a little check.
but
If you want to get
so you can put stage
I think it'll give you the first page. If it's a big
Yeah.
PDF, you have to use a different
It's just
version.
one.
so
But
it's,
okay, I'll mess around.
so this is the
Oh yeah. There's.
Yeah, I just want to
There's also a way to include like a whole PDF document. That's what the logic is.
oh,
You see a package called PDF appendix.
that's a good question.
Yeah.
So you want to look for
Yeah.
So I can try to help you with the room lights and stuff, but you want to project some slides too, is that right?
Yeah, I'm going to use the slides quite a bit actually. So
Great.
Actually, now that I look at what you did, I think maybe use single dollars.
Okay, so
Actually, wait, you're supposed to use any dollars.
is it on?
Yeah. Yeah. That's good. So you probably don't even. Sure.
nice to meet you. Yeah.
Using EQ analyze versus analyze. That would be a lighter EQ analyze. In that foil. It is copy.
Oh, I can use an equation. Actually, the one.
Okay. I don't know why this is.
So this is probably his computer. John, do you ever use this, Sage?
Oh yeah.
Yeah, I
like it a lot.
do. Yeah, I use it quite a bit. I really like it.
UW is actually the center.
Yeah,
of it.
William Stein. Yeah. Okay. You all EE 361? Some of you?
None of us.
None of you. Oh, all right.